Okay, guys, today's homework, really simple. The last 2 pages of this section, we're doing page 243, 244. Right now, we're opening up to page 237. Okay, so we're going to start here on page 237. I'm sorry, 231. Did we do this one last class? I had some classes that made it this far, some that didn't. Did we do the whole page? I thought we just started it.
No, we didn't.
Okay. So I'm going to run through this just for the recording because all the other classes need to do this one. But since you guys already did it, we're just going to go through it right now. Okay, the graph represents the number of gallons of water used for the number of loads of laundry washed. Write each point on the graph as the ratio of gallons of water used to the number of loads of laundry. So I've really enjoyed our new curriculum. This is one of the first things they've done that I really don't like because they reversed the order. Normally we go X, Y, but they asked us now to write it gallons of water, which is our Y-axis, compared to the loads of laundry, which is our X-axis. So make sure when you're writing your ratios, you pay attention to the directions that they give you and write them in the correct order. So they've only given us 3 points. Our first one here is at 18 and 2. Our second point, we go up here, so that's halfway between 26 and 28. That makes it 27 and 3. And then the fourth one they gave us is 32, 4, 6. And comes down at 4. So what do you notice about each ratio? Legend?
Laundry times 9 to get the gallons of water used.
Good. So, I love the way you said that one, Karina. Good job. They are all equivalent to 9 to 1. So kind of what Legend said, but that's putting it in the ratio format and using the math language of equivalent ratios. How many gallons of water would you use for 7 loads of laundry? How did you get there, Legend?
So since it's times 9,
Okay.
you have to do 7 times 9 to get 63.
Okay. So you just said 9 gallons, 1 load. I need how many gallons for how many loads? And they said it's 7 loads. So my magic box, how do I go 1 to 7 is times 7. 9 times 7 gives me 63 gallons. Aubrey, you might want to write this down instead of coloring your pencil. So you need 63 gallons. Okay? Did anybody see a different way to do that one? Actually, because we have the ratios written up here, guys, a very easy one would have been, if I need 7 loads, I can do 3 plus 7, right? Or 3 plus 4 to get me 7. And you have to add this. Remember, when I do additive, I'm adding the parts. So I add 27 and 60 and 36, and I get 63. Legend, you look confused. Which part didn't you understand on that one? You do? So guys, remember, we can look at it from an additive relationship, but when I do additive versus multiplicative, I use the same number times each part. In additive, I have to use the amount that's in those boxes. So I have to use 3 and 4, then I have to use 27 and 36. So that's a big difference between how you're looking at that additive versus multiplicative. So how many loads of laundry do you use for 45 gallons?
5 loads of laundry.
How'd you get that one, Legend?
So 45 divided by 9 because I go by 9 equals 5 because 5 times 9 equals 45.
Okay, interesting, because our base ratio is here. So if we go 9 gallons to one load, excuse me, equals 45 gallons. How do I go 9 to 45? Times 5. So 1 times 5 gives us 5 loads. So you can do 5 loads. Did we use the same method? Legend did. Did I use the same legend as you guys? Do you have to use the same method?
No.
No? But in this case, we did. But it's okay to switch between methods, guys. That's why we're showing you so many different ways to do it. But in this case, we went back to our base relationship and then just showed our magic box how we got from one side to the other. So you're really not going to write any of it, Aubrey? Your pencil's looking really pretty, though. Good job coloring it. Questions on this page? Okay, let's go to the next page. So we're going to start with this ratio. Augie burns 225 calories for every 30 minutes he rides his bike. So we've now have given you a table. You need to complete the table to chart the number of calories burned, then plot the table values on the graph. So you're going to fill the table out, plot it on the graph, and then use your graph to answer each question. So we really want you trying to use the graph, not the table. And you've got 2 questions on that, and then part 5, how is the graph helpful? And were there any limitations when using the graph to determine values? I'll give you guys about 7 minutes to knock out this page. You can work together as a table. Okay, for our table, they gave us our first entry. We know that at 30 minutes it was 225. So the first question I got to ask myself, how do I go from 30 to 10? That one I'm going to divide by 3. So I divide the top by 3, and I get 75. At this point, I've got a lot of different options. But for me, when I see 30 and 60, I always like multiplying by 2 because that math is pretty easy. So I'm going to take the 275 times 2 to give me 450. Next one is where I'm probably going to differ from most of you, because I don't mind doing additive, subtractive reasoning. Most of you are stuck in the multiplicative, which limits some of your options. But for me, when I see 50, I say, oh, wow, I got 60 and 10 already, right? So I can just subtract 10. But if I'm using the additive relationship, which subtraction is just the opposite of adding, then I can't use 10 on both sides. I have to use that value. So on the top, I'm actually going to subtract 75, or 1 interval's worth, meaning I'm going to get 375. Had you done the multiplicative way, you would have still gotten to the same answer. Okay, the second part was then plot these points on our graph. So I now need to go through. So my first point was at 1075. And by first, I mean the lowest number. My next number is 3225. So 30, I come up to 225. 50, 75, and just so you can see on YouTube what I'm doing, I always start at origin, come over to 50, and then I come up to 375. Make sure I do it right this class. Last class I was off by 1. Then my last point is 60 and 450. So again, I start at origin, I go over 60, then I come up to 450. Once I have all of them written, this now allows me to find points that are in between. So one key on this, you must use a straight edge to get a solid line through this. If I don't use a straight edge, because I can't on the smartboard, you'll kind of see this, my line is not nearly as good for making accurate predictions on intervals or on predictions beyond my last data point. So basically all we're going to do is we start here. I'm coming up And I'm trying to do as well as I can to keep a straight line, but it's not entirely possible because I can't use a straight edge on the smartboard. What this does do, though, is now allow us to look at some of these in-between intervals. So how many minutes would it be for 150 calories? All I do is I go to 150 calories, I come over to my line, I find where it intersects, and I come down, and that would be at 20 minutes. Okay? So it will take 20 minutes. Does everybody see where that came from? Okay? Part 2, about how many calories can he burn if he bikes for 25 minutes? So fortunately, they gave us some wiggle room here with the about. So if I go at 25 minutes, I'm going to start here. I come up, and I see that it intersects somewhere in the halfway point between 175 and 280. 175 and 200, meaning that's going to be somewhere around 180, and it's just above that. So I'd probably say about 182 minutes. Or calories, sorry. Wrong description. Does everybody understand where we got that number from? But it also, I'm glad they did that interval because it points out one of the limitations. So how is the graph helpful? When it's directly at an intersection point, right? That made that first point really easy to see, didn't it? So it's helpful when the line crosses directly at both axes. In other words, the X and Y are very clearly lined up. It's limited on the exact reading between lines. So if it's in between the intervals, it's not nearly as beneficial as when it crosses directly on the 2 points. Okay, you should make sure you have all this written down. You should make sure you have all of this written down. Okay? I'm sorry? Yes. So while I had a pause, we were talking about when we get into more advanced algebra and there's graphing on graphing calculators, you can actually trace the line. The calculator will actually tell you the exact coordinates for every point on that line. So Brock asked if they sold them. They do sell them, but they're not as expensive as they used to be, but they're still pretty expensive. So I wouldn't recommend going out and getting one until you get into high school. That looks like a lot less than what I have written. It depends. You can get some that are several $100s. Most of the high school level calculators are just over 100. Okay, let's go to our next page. We're on 233. So we're going to now analyze graphs of linear relationships. A lot of this is going to call back to what we have already done.
Please pardon this interruption. This concludes the interruption.
Oops, it didn't pause. So you guys got to hear them calling Toru-san to the front office. Okay, consider the relationship modeled by each graph. So we got a couple questions on this. Determine whether each graph represents a set of equivalent ratios. So if I look at plant A versus plant B, which of those do you think has equivalent ratios, if either of them? Jaden? Why do you say that?
Because it goes through version.
Wow, you said it perfectly. Great job. You used all the math terms and everything. Graph A, or plant A, is equivalent because The line goes through origin. And as a reminder, origin is the point here, 0, 0, where the x and y axes meet. Later on in the year, as we get into negative numbers, you'll see that that actually extends in both directions into negative numbers. But for our purposes for now, we're only looking at the positive portion of the graph. Brian, get your feet down. Okay, what about plant B? Does that have equivalent relationships? Why not, Legend?
Because it doesn't go to, it's not equivalent to the origin.
Good, it doesn't go through origin. Not equivalent because it doesn't go through origin. And honestly, guys, your logic is that simple. Okay? Consider the graph for plant A. What does the point 0, 0 on the graph of plant A represent? What does that point represent?
The origin.
It is the origin, but in terms of the plant, what does it represent?
Zero time and zero growth.
Okay? So, at the start, the plant had 0 growth. Okay? How many centimeters did plant A grow each day? There's our question. So I go to my graph, starting here, going over to day 1, I see I go up and it grew.
2 centimeters.
Right, Aubrey? You see that? You should probably mark it in your text too. So it grew 2 centimeters each day. Now consider the graph for plant B. What does the point 0.03 on the graph B represent?
0 days, 3 centimeters in growth.
Okay, so it means what?
The origin.
Not the origin. It started at 3 centimeters high. Okay, and then after that, how many centimeters did plant B grow each day? How'd you get that one, Legend? Because if I start here at 3, I go over 1. Did it go exactly? Is that right on that dot?
No, it's unseen. Centimeter and
A little bit more?
Yeah.
So the easiest way to figure it out exactly is to figure out where do I see it cross exactly at 2 lines again. So day 2 still doesn't. Day 3, not quite. Day 4, there it's going straight across, isn't it? So in 4 days, I can figure out that in 4 days, it grew how much? It went from 3 to 8. So how much is that for each day?
1 centimeter and 1 and 1/4 centimeter.
1 and 1/4. Does that make sense with what we saw on the first day, that it was just over 1? Okay? Does everybody understand how Legend got the 1 and 1/4? Anybody not understand? Maybe a better question. If you don't, it was 5 centimeters in 4 days. You guys all know how to turn that from a improper fraction to a real proper number, right? So that's 1 and 1/4 centimeters each day. Is everybody good on that one?
Yeah.
Any questions on how we analyze those 2 graphs? One of the big keys on all of that, guys, was that fact that you get your best use of the lines is when they hit directly at intervals, and we know they're equivalent when it goes through origin. If you remember those 2 things, that's the 2 key lessons for today. Okay, let's go to page 234. Okay, two different jogging situations are given on the next two pages, along with a diagram showing the recurrent relationship between the joggers. So, cut out the diagrams, equations, graphs, and verbal statements located on page 241. I'm actually not going to have you guys do that. I'm instead going to have you just draw arrows on that page to connect them. So choose and affix the diagram that shows the relationship after 5 minutes, and then affix the equation that best represents the relationship. So basically you're going to choose which one goes with which graph. Make sense? Okay, so we've only got a few minutes left in class. Because of the fire drill, I'll give you guys about 4 minutes to try to figure as much of these out as you can. Okay, here's your homework for tonight, page 243, 244. The first part, journal entry, make sure you've done that. The second part, creating the graph to represent the values shown in each ratio table. So you're doing two parts on this, really. They gave you the table. All you're doing is create the graph. So apparently my pen's not going to work on this. So make sure you chart the values on the graph. Then, what is the cost for 3? What's the cost of 21? You can either use the table values or your graph. The idea is to try to get you to use the graph as much as possible. Second problem. Now we're doing the same thing. They gave us another table here. You're plotting those values. What's the distance at 6 and the time at 275. Third problem, exactly back page, you've got another graph. They also gave you a table. The only difference on the last problem is they didn't give you the table for number 4. So for number 4, you're going to have to figure out how do you get to those values, okay? So in this one, they've given you the graph. So you can either make a table like they did in the other ones, or just use your reasoning. Quite honestly, if you use a straight edge and draw in your line, you should be able to go up to 4, and it should come straight across for you. You can do the same thing on the 48 if you have done your lines. Questions on your homework?
No.
Legend, why are you already at the door?
Just Legend.
Don't do that. Okay, guys, good luck.